Hello, physics friends. Today in class, we discovered something in the little test called significant figures. And I noticed that some of you had a good idea of it, but others, we have never seen it before. Well, in physics, the number of digits in a value that we report tells us about the level of precision of the instruments that we used. Okay, so we read numbers and we can read into it to see how much we can trust the measurements of others. Okay, and physicists will never report a number that they don't believe in. All right, so significant figures are really important to keep those numbers in our calculators down. Often we get a lot of numbers from doing a calculation. For example, when you divide by 3, you get all these repetitive numbers that go on and on forever. How many of those do you have to put down as a final value? Well, in physics, we get our values from measurements. So if you take a look at this drawing over here, here are two very imprecise rulers, one measuring in inches, a unit that we don't use in physics, and the other measuring in centimeters, okay? And these are imprecise. We can't really read into it. I might be able to look at the centimeter reading and estimate that the length here might be like 15.9 centimeters, but I don't really have a precise way of saying that. So if I was gonna be a little risky, I would say that the measurement of that ruler is 15.9 centimeters. But that's pushing it. That's pushing it to say that I can read millimeters in that marking. So that would mean that my significant figures here are limited by the tool, 15.9 centimeters. That's as many. I couldn't go further than that. Okay, there's no way I'd be able to look at that and say it's 15.994. I can't do that. So this tool is limiting my precision. So then how do I carry that measurement on into other calculations to limit the precision of my final calculation? This is really important. If you're an engineer, you have to make sure that you are very accurate and precise about your measurements, but also that you're not going to say something is perfect if the measurements were not. Okay, so for engineers and physicists, we use sig figs. So here are the rules on how to identify how many significant figures are in a number. First of all, we got to look at zeros. Zeros are usually not significant in certain cases. All right, so a number is a significant figure if it is not a zero, okay, like this number over here, 4.5 grams. In this case, 4.5 grams has two significant figures. You probably can guess, 1, 2. The next number here, 122.35, has 5 significant figures, 1, 2, 3, 4, 5. Okay, but now the next number has a 0 in it. How do we treat that 0? Well, if the 0 is in the middle of the number, it's significant. So I can count that as 1, 2, 3 significant figures. Here it's in the middle, 1, 2, 3, 4 significant figures. Okay, now what do we do if it's at the end of a number? Well, if I have a 0 after a decimal place, well, that 0 is telling us a little bit about our instrument. That's the accuracy or the precision of the instrument. So here, 25.0 would be 3 significant figures, and 16.00 is 4 significant figures. It's telling me that my meter is measuring 0.01 grams. All right, now if I have a 0 written in scientific notation, if it's here at the end of the decimal, that's definitely 3 sig figs. And here, there's no zeros in there, so this is 2 sig figs in the scientific notation. When a 0 is not significant is when it's in front of numbers. Okay, even though it's in the decimal places here, if it's in front, they're not significant. So 0.0004 is only 1 significant figure, and 0.075 is only 2. Okay, if it's at the end of a number that doesn't have decimal places, we often think that people have cheated, they've rounded in order to get those numbers. It's very rare to have numbers that end so clean like that. So we try to avoid these types of situations and would say that here are only 2 significant figures, that doesn't count. And here are 3 significant figures, and that doesn't count. And all these sig fig rules are there to help protect our measurements and our reliability. We're not going to say something is true if we don't believe in the instrument that we use to measure it. Okay, so then how do we use these sig figs in calculations? My final answer has to reflect the accuracy or the precision of my measuring tools. Okay, so the final calculated values are always limited by the least precise measurement. Okay, in this case, I have, let's just write this down, I have 2 sig figs. I'm going to change the color Here I have 3 sig figs. Okay, and if I would multiply these two numbers together, I'm going to get that big number, but that number has a lot of sig figs. And in my measurements, I have one very weak measurement that only has 2 sig figs. So my final answer has to be a maximum of 2 sig figs. That's my least precise measurement tool. So 1.3 times 10 to the 4 is going to be my final answer because the answer only has 2 sig figs. Okay, so we're limited by the smallest number of sig figs in multiplication and division. 6.244 divided by 1.25. Okay, this would be the final calculation. Here I have 3 sig figs. Here I have 4. Okay, so my answer needs to be 3 sig figs, which would be, in this case, I'm rounding up, 5.00. Okay, that's 3 sig figs. And recognize that 0.00 in this case is significant because it's at the end of a decimal place. 12.3 to the power of 3, that's like multiplying by itself 3 times. The base has 3 sig figs. So that means my answer has to be 3 sig figs. Okay, so 1.86 times 10 to the 3 would be the answer there. And in this case, you see these zeros, there's no decimal places, so they're not significant. So this number here is 3 sig figs. My answer has to be 3 sig figs, which would be 243. Okay, so that was for multiplication and division. What happens when we add and subtract? Well, adding and subtracting, it's the law of the least decimal places. So here I have 2 decimal places, here I have 1 decimal place, which means my answer needs to be 1 decimal place. So 7.3. And in this case, I have 3 decimal places and 2 decimal places. My answer needs to be 2 decimal places, which is going to be 9.22. All right, you're going to have a lot of practice and you're going to learn sig figs, and a lot of stuff that we do in chapter 1, you're going to learn by mistakes. Okay, and that's okay. Just recognize that on every exam and in every report that you write, you're going to get a comment about sig figs or precision, accuracy, the orders of magnitude. You'll have a lot of chances to practice it. But if you don't learn the terminology right now and what this means, it could become a very frustrating experience as you're going through. That's why we're doing this first. All right, hope this helped.